Today we'll start with the topic called data types. Okay, so what are these data types? We'll see. So what is a data type? What is a data type? Data type means we already see in the C, C++, and some programming languages. No, so data type. So data type is nothing but data types are what kind of value a variable holds. Okay, what kind of value? Okay, what kind of value the variable stores. Okay, the variable stores, that is nothing but a data type. Okay, how the computer is storing that data in terms of which, like, either it may be like a int data type, integer data type, net data type, while data type, like that. Okay, so in this very log, first you have net data type. Net data type. Okay, so net data type is nothing but it is used to represent the physical connections. Okay, used to represent only physical connections. Okay, represent the physical connections. Physical connections. Uh, so, so this is this is used to drive the values continuously from the driver. Okay, so used. These are used to drive the values. Okay, whatever the values are there, values continuously from the driver. So by using this net data type, you can't store any value. Okay, so by using, this is very important, by using net data types, these are not storing any value. Okay, these are not storing any value, not storing any value. Okay, so this is net data type. So like suppose uh, uh, suppose here, let us take suppose 22 is nothing but this is a decimal. No? This is nothing but decimal. Suppose a equal to 22 means we need, so a equal to 22 means what? So that means this variable, whatever this variable is there, I want to store in the memory location. So we need to define the data type now. What is this a? We need to define what type of data type. Okay, so we need to define the what type of data type it is. Okay, so for this we are using net data type. So net data types, you have three types are there. One is wire, var, and van. Wire, var, and van. Okay, these are the three types of data types. Mostly in the Verilog, we will use this wire data type. Okay, wire data type. Okay, it will not store any value, just it will try the value. Okay, suppose how you are declaring, suppose like module example, and wire a. Okay, so wire a and end module, wire a and end module. So what is this? Wire is nothing but data type. This is a keyword. Wire is a keyword. Okay, and what is a? A is a variable, or it can be identifier. Variable or identifier. So did you understood this? Okay. So like where you are using net data type means, where you are using net data type means, suppose like you are having two modules. Let us take module A, and next is module B. I want to connect with module A and module B. Okay, and here so for connection of this one, I am using this net data type. Net data type. Okay, so here what happens? Module A will drive suppose one value, drive some value, and module B will receive this whatever the driven value. Okay. So here in this situation, I can use net data type. Okay. So the value will be not stored in anywhere, just through the wire. So we can connect, we can drive the values. Okay. Um, so for suppose we are driving the values. Actually, we are not storing. We are not using for storing any value. So net data type means what? We are not using we are not using for storing any value. Just we are using for driving the value. Okay, we are using for driving the value. Okay, and suppose example, let us take wire A, wire B. I'm using. I need to use a special keyword that is nothing but assign. When you are using like wire, I need to use a keyword called assign. Okay, this is one keyword. This is continuous assignments statement. When we discuss the data flow modeling, there you will get. So that means here I need to assign b equal to 0. Suppose if I want to assign any value to this variable, uh, so here this is 0. So this 0, so I am driving this value to the 0 value to the b. Okay. So it will continuously drive that value into the B. It will not store the value, just it will continuously drive the value to this B. Okay. And what are the default values? Default value. Suppose if I give wire A. Okay, this is very important interview question. What is the default value for wire data type or net data type? Wire A. If I consider wire A, what is the default value? We already seen the value set, no? What are the value set? 0, 0, 1. Hmm. So the value can be from these four. So can you expect what is the value? No, default value is Z. Z. So that means here Z is nothing but last class we already seen, no, high impedance are not connected, no, not connected. So that means when you declare the wire, so inside the that compiler will understand that this wire is not connected. This wire is not connected. So what is the default value for wire means? You need to remember that default value for the wire is what? Z. Is it fine? Okay. And next, so suppose so in the net we already seen what are those. So we seen about wire, and next we need to see war, and next WAND. Wire, war, and WAND. Okay. So let us take one example. Module, module example. I'm using assign a equal to 0 and assign a equal to 1, and I want to display. I'm using a system task dollar display the value of a. The value of a is percentage d comma a, and percent percentage d is nothing but format specifier. Format specifier. Okay. So that means we already seen suppose percentage b means you need to display in terms of binary. Okay. Percentage o means you need to display in terms of octal. Percentage d means you need to display in terms of decimal. Percentage h means you need to display in terms of hexadecimal. Okay. Now tell me what is the value of a. So starting class I told you Verilog. Verilog is which language? Verilog is a Okay, that is concurrent language. Concurrent language. Concurrent language means what? Both instructions will be executed parallelly. Whereas software languages C, C++ are sequential languages, one after the other. Yes, that will be executed one instruction after other instruction. So that means both instructions will be executed parallelly. Yeah. So I'm asking that when you display this value, what is the value of A? First A becomes 0, next A becomes 1. Mm-hmm. So both are executing parallelly. So what is the value of A? Value is X. Output is output is X. Invalid. Why? Because don't care. It means compiler can't predict either value is A is 0 or 1. No, both will execute parallelly. One time A is assigned to like 0. Other time afterwards A is assigned to 1. Both will be executed parallelly. You are getting the output equal to what? X. Invalid case. Okay. So in order to overcome this, we are using which data type? You need to declare with var and van. Var and van. Suppose if it is var is there. Suppose if we are using var. Okay. Same program I am writing. Example module example. I am using assign a equal to here I declared y data type. No, here I need to declare y data type. Y a. Okay. And here I am declaring var a. Okay. Var a. And assign a equal to 0, and I'm assign a equal to I'm making a equal to 1. dollar display dollar display, the value of a the value of a is percentage, let us take percentage b or percentage b comma a and end module. Now tell me what is the value of a? Both will be executed, but I declared with war. War means what? OR operation. That means it will be 0 R of 1. So that means here A equal to what? 1 you will get. A will get 1. A will get 1. And next, suppose if you are using WAND, in place of this code, if I am using WAND, what it will do? AND operation. It will do AND operation. So WAND means what? So that means 0 AND of 1. It will display. So that is A value equal to what? 0. Now you understood the difference between this why data type. Okay. So why the van, the war? These are some interview questions only they will ask. Okay. Suppose this is also very important. Suppose size of wire. If you take, uh, suppose if I consider wire A, what is the width of this? No, this is 1 bit. This is 1 bit only. A can store only 1 bit only. Suppose here, I am giving that is assign like a equal to 0. Okay. And a equal to 0 means this side is 32 bit. This is okay. You are correct only. But this side is what? 1 bit. This is 1 bit. So normally in the compiler how it will store? So this is LSB bit 0 0 up to so on. This is 0. So this is 0th bit. and this is 31 bit. Okay. So this LSB value will be stored in A equal to 0. Suppose if you are giving like assign A equal to 1. Normally in the compiler how it will store? This is 1 bit only. This is how many bit? 32 bit. 32 bit means 0. So that means 0, 0, 0. Again this is 1. 0, this is 0th bit and this is 31 bit. So A will be stored as this LSB bit. This is LSB, no? Yes, yes. The value like only LSB will be stored. LSB 1 bit will be stored. As this is A is 1 bit, so A equal to 1, that is in binary only. Did you understood this? Okay. And next we'll go with range data type. Range data type. So range data type. By using this range data type, we can able to store the data. We can able to store the data. Okay, we can able to store the data. Okay, suppose here let us take one example, module example. I'm considering the regex. Okay, I'm using the initial and I'm giving a equal to 0. Okay, and end module a equal to 0 and end module. Okay, so this 0 is there, no? So we can store, that means we can store 0 into a. Why? Because you initialize with this is the x, or otherwise you consider it as a. Okay, so we can store 0 into a. So why? Because you declared a with which data type? Register data type. Okay, uh, okay, that register is different, this is different, register. Okay, okay, so this is also one bit. This is also one bit. So that means here this is one bit. This is how much? 32 bit. So that means here A equal to what? The LSB bit 0 will be stored. Okay. What is the default value? Default value is 6. Unknown. Default value is unknown. Either it may be 0 or unknown. Okay. Suppose here if you see like reg A initial A equal to 32 and giving A equal to 32. So what is the value of utility? Reg A, this is one bit only, no? No, no, here 32 is there. No, 32 means what? It will be converted into binary. 32, 1, 2, 4, 8, 16, 32, 32, 32, 32 means 32 minus 16, how much you are getting? 16, 32 minus 32 means what? Yeah, 32 minus 32 means what? 1 only, no? This is 1 and remaining are 0. Okay. This LSB is what? 0, no? So A will be stored with 0. LSB bit. It will store the LSB bit. Only LSB. Why? Because it is 1 bit only, no? Okay. Did you understand? This 32 is what? Decimal only, but this is what? This is 32 bit. Actually, this is 32 bit. So that means here how many bits you got? 3 and 6 bits you got. No. So 1 0 0 0 0 and before this like 30 bits are there. Okay. So on 30 bits are there. So this is 0th bit and this is more 31 bit. So you declared a reg A, no. This is only 1 bit. Only LSB will be stored. So that is equal to 0. Is it fine? Did you understand? Least LSB value is whatever that LSB value is, that will be stored. Okay. Next, we'll see with so if it is one bit, suppose if I want to if I want to store multiple bits, so you need to go for what we already seen vector mux, no, the distance. So same vector mux, okay. So same thing, vector concept will come, vectors, okay. So vectors are nothing but what grouping the multiple bits into single variable, grouping the multiple bits into single variable, single variable. Okay. The syntax will be like this. Data type, and next you have range, next you have variable. So range can be, data type can be what? You can use the range data type, or you can use wire data type. Okay. So only two data types you can use in the vectors. Okay. And next range. Range is nothing but MSB down to LSB or LSB to MSB. This is nothing but down. MSB down to LSB. This is LSB to MSB. Okay. So mostly we will not prefer this. We will prefer this one. MSB down to L. Okay. MSB down to L. Okay. And the variable is anything you can create a B or X, anything you can take. Okay. Is it fine? Suppose if you want to store like three tick binary 0 1 1. Okay. How to write the example module example, and I am declaring reg how many bits? Index is what? 0 1 2, 3 bits. 2 down to 0, no? A. Go down to 0, A. A equal to what? 3 tick binary 0 1 1 and end one. Like this, I can represent. Is it fine? So these are nothing but indexes. 0 1 1 is what? 0 1 2. This is nothing but index. Okay. Suppose if I want to store 4-bit value, 4 tick binary 0 1 1. Okay. How it will store means like so it will make the locations like this. Okay. Like this is the index 0 1 2 and 0 1 1 will be stored. Okay. And suppose if I want to store 0 1 1 1. Okay. So I need to like standard representation. How I need to represent reg 3 down to 0 A. Okay. 3 down to 0 A equal to 40 binary 0 1 1 1. Okay. Suppose reg 3 to 0 to 3 A. Okay. We are not using this. Okay. I told you, no. Mainly we use this notation. LSB to MSB will not use. Okay. There is a concept called big endian and little endian now. Okay. So that means the first MSB will come, next LSB will come. So this will not prefer. Is it fine? Okay. And next, if you see, suppose reg 5 down to 0, I am considering M. Okay. So I want to store some value. M is how many bits? 6 bits. Yeah. So 6 bits means 1 0 1 1 1 0. Okay. I want to show 5 4 3 2 1 0. Okay. Uh, So, like vector slicing, vector slicing. What is vector slicing? I can access all bits. I can access, suppose I'll write module TB, reg 5 down to 0. I am considering the same. Okay. And uh, and next I am considering reg 1 down to 0. 1 down to 0. I am considering as n. Okay. M equal to what? I am giving 6 tick binary 0, triple 1, 0, 1, 0, 1, and end module. End module. Okay. End module. And here I am declaring, suppose I can access these values of 0, 1, separate values. Suppose if I keep n equal to m, 3 down to 2. Okay. So what are n values? Tell me. Only double one. Double one. So 3 is to 2, no? 3 is to 2 means 3 down to 2 means only double. Okay. And next, suppose if I am writing like I am declaring reg a comma b comma c. Okay. And or 1 down to 0. Let us take 1 down to 0. This is a module TB, reg 1 down to 0. Okay. 1 down to 0. So ABC. So what is the width? What is the width of ABC? Ah, 2 bit. Each and every bit, sir. A is 2 bit, B is 2 bit, and C is also 2 bit. 2 bit. Okay. Suppose if I write a module TB, reg 1 down to 0, A, semicolon, and B. If this code will execute, here which is missing? Reg 1 down to 0, A, semicolon, and I wrote B. End statement. Yeah. I wrote B. I wrote B. I wrote B again semicolon. So here which is missing? Yeah, you are getting the compilation error. Here data type is missing now. You declared only like variable only, but you have not declared any data type. Okay, so that means semicolon is nothing but what? End of the statement. Semicolon end of the statement. Okay, end of the statement. And next, like if I yes, yes, yeah. Reg 1 is to 0, A semicolon. Again, I will write reg B. It will be valid. Hmm? Okay. Ah, yes. Hmm. Okay. Next, you see, suppose module example, module example, input, input A comma B and 1 down to 0, C. Okay. So that means remember that I not declared the data type. By default, it will take as which data type? Reg or byte. It will take as byte data type. Okay. If you are not declaring the data type, by default, compiler will take as byte data type. Okay. So this is 2 down to 0 sum semicolon. So if you see this one, any compilation error will be. see here. So here semicolon, this is nothing but end of the statement. So this is nothing but end of the statement. Here you need to get comma within the bracket. You need to get the comma. So that means here semicolon should not be used inside the bracket. This semicolon is there now. So this should not be used. Should not be used inside the bracket. Yeah, yeah, yeah. Hmm. Okay. Suppose like if I consider range 2 down to 0 a and a equal to 6. So inside how it will store? Hmm? 110. So a will be stored as 110. Okay. So 110. Okay. Suppose like I will give range 2 down to 0 a and 2 down to 0 a. These are how many bits? 3 bits. Okay. Range 2 down to 0 b. Okay. 2 down to 0 b and giving a equal to 6 b equal to minus 6. Now how it will show? So a equal to 110 it will show. B value triple one. In digital I told you like whenever any compiler or computer is there that it will want to store the negative number, that negative number will be stored in each form. So complement form. Yeah, it's a two's complement, no? You have time magnitude once, yeah, time magnitude once complement and two's complement. So why it is two's complement means only one representation for zero. There I told you no. Okay, only one representation for zero. So that means here, like one's complement means what? 0, 0, 1. Adding one to this 0, 1, 0. Okay, so this is two's complement. Normally it will be stored in terms of what? Two's complement. Okay, two's complement. Suppose if you want to display in decimal this value, this is nothing but what? It will display like a 2 only. This value it will display like a 2. Actually, this is display like a 2. Okay, understood. It will display like a 2. So from this, what you can conclude means whatever the wire data type, wire data type, and range data type, range data type are unsigned data type. They will store the negative numbers in two's complement. Suppose if you want to display this two's complement number, then it will store in terms of what that value. Actually, that value. So that is 0, 1, 0 is nothing but 2 now. So that's right. So that means the reg and wire data type. So whatever the reg and wire data types are nothing but unsigned data type that will only store positive numbers. Only store positive. Means they only store the positive. Is it fine? Okay. And next you have integer data type. Integer data type means in order to store the signed numbers, you are using integer data type. Okay. In the C language you have int data type now. But in Verilog, you have integer data type. Okay, so it can store the value. It can store the value, and it can be synthesizable. Synthesizable means what? We can convert into hardware. Reg and wire also synthesizable. And this is signed data type. Signed data type. Okay, and what is the width of this data type? This is 32 bit. Width of this data type is 32 bit. And what is the default value? Default value is x. Default value is x. Okay. Suppose if I consider integer a equal to 2. A equal to 2. It will store like 32 bits. That means this is 0, 1 and all are zeros only. So on, this is 0. So this is 31 bit and this is 0 bit. 0, 1, 2, like this. So these are packed. These are packed. Packed data type. Packed data type means vector slicing is not possible with the integer data type. Vector slicing is not possible. Okay. It's a 32 bit. Which is 32 bit. Actually, reg A or wire A. This is how many bit? 1 bit. But integer is a 32 bit. Okay. Suppose if I want to access like integer 3 down to 0 A. Okay, this is not possible. Why? Because we can't use. Why? Vector slicing is not possible. Vector slicing is not possible. Is it fine? Did you understand? Okay. And next is float data type. Float data type is nothing but we can store keyword is real. What is the keyword for float data type? We need to use real. Okay. So this is used to store the fractional values. Fractional values. Okay. So here and this size is 64 bit. Size is 64 bit and default value is x. Default value is x and this is signed data type. Signed data type. Okay. And next you have time data type. Time data type is used to track the simulation time. Used to track the simulation time and size is 64 bit. Size is 64 bit and default value is x. Default value is x and this is unsigned. Signed cannot be negative. No? Unsigned data type. Okay. So this is represented with the dollar type, like dollar type. Like this it will be displayed. Is it fine? So what are synthesizable and non-synthesizable data types? Synthesizable constructs and non-synthesizable constructs. Okay. Synthesizable constructs. Synthesizable constructs. Synthesizable constructs are nothing but what? Which can be converted into gate level netlist. Yeah, which can be converted into hardware or we can call as gate level netlist. Gate level netlist. Okay. Non-synthesizable construct means yeah, they cannot be uh, converted into hardware. Yeah, non-synthesizable means verification. Yes, yes. Now tell me, in this data type, what are synthesizable and what are non-synthesizable? Wire, wand, var, reg, vector, integer. These all are synthesizable. Okay. And next, float, 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 time. Okay, these are non-synthesizable. Is it fine? Okay. We understood about the data type. Just show you this codes. I wrote some codes for this data type. I wrote it. I told you need to like need to uh, install this GVim software. Okay. GVim. Okay. Okay. I will share this just to go through this. So this is the example of wire data type. Okay, wire temp assign temp equal to A and B and assign Y equal to temp like this. Input and declaring like input A B C A B and Y like this and declaring. Okay, this is wire data type. And this is the example for reg data type. Okay, so reg example. mm, Input and declaring input clock reset d and output. So this is behavioral modeling that I will tell you. When you are using behavioral modeling means output you need to declare with the reg data type. And this is always is synthesizable. I told you always at the rate passage of clock or passage of reset begin if reset q equal to 1 tick binary 0 else q equal to d. This is the simple code for deep network. Okay, here I am using reg data type. Okay, and this is vectors. Vectors I told you now. So multiple bits if you want to declare, so you need to use vectors. Okay. So input 7 down to 0 A, input 7 down to 0 B, output 7 down to 0 sum, assign sum equal to what A plus B. Like this. This is one example of vectors. Okay. And integer data type using. Integer data type means uh, so see here. Module integer example, integer I, initial begin. For I equal to 0, I is less than 10, I equal to I plus 1. Dollar display, the value of I is percentage d comma I. Okay, end module. So what it will display, tell me? Yeah. Hmm. Hmm. So here, yeah, get my to show. Just I'm copying this. Mostly for Verilog, you need to use this EDA playground also you can use. Okay. And Xilinx Vivado I told, no, I shared one video. Need to install that. Okay, okay, okay. You can use that. Okay, you can use that. So here you need to like EDA playground. This is open source. You need to register with your mail ID. Need to register with your mail ID. And here you are going to write the design. Here you need to going to write the test bench. Okay. Right side design, left side test bench. Okay. So I'm writing the design. And languages means you need to select Verilog or system Verilog. And tools and simulators, you need to select the Aldec Rivera. Okay. Tools and simulator is Aldec Rivera. And just save this code and run this code. So you are getting the output now, the log file. So like this, you get that. So on 9 will be. Okay. Any doubts? This is it. Zero means here, if your zero is not given, means you get like spaces. In order to avoid the spaces, the space is coming. Yeah, in order to avoid that, you need to keep zero. Now it will get like I equal to, after I equal to, we will get zero. Like, you observe the change, no? Okay. Next is real data type. This is one code for real data type. So here if you see a module real example, real voltage initial begin. Voltage equal to what? 3.3. Dollar display. The voltage is percent. You need to use a format specifier. This is float data type. No. Float data type means percentage of V comma voltage. Okay. So V comma voltage, select, copy, and see in the PDF playground. Just copy here, save this file, and run this file. Voltage will be like this. It will be this. Okay. So CC equals 0 volt, it will display. Same thing you are getting. Next, time data type. This is nothing but time data type. It will execute the simulation type. Okay. Suppose I declared two times, time t1 comma t2, initial begin. T1 equal to dollar type, hash 50, t2 equal to dollar type, dollar display. The time difference is percentage d, t2 minus t1, end and end mode. Okay. Just subtracting the two times, t2 minus t1. So what is the initial time? T equal to 0 only. Yeah, means here you initialize the dollar time. No? So you not declared any delay means it will start from t equal to 0 time units only. Okay. So that means 50 minus, now you given the delay. After that again you given t2 equal to dollar time. So 50 minus 0. What you are getting the output? 50. Yeah. So see the just see the background. Run this code. Time difference is how much? Got the output. T2 minus T1. Did you understood? Shall I move forward? And next, this is a reg comparison. I need to compare this like two reg values. So I'm declaring the. So if I'm not declaring any data type, means it will take as y data type only. No? Input A, input B, input select, output Y, range temp. Always at the rate star means this is implication operator. So it will be applicable for all the inputs. Okay. So no need to declare the sensitivity list in the within the bracket. So if select temp equal to A, else temp equal to B, and assign Y equal to temp. Okay. So I'm not displaying that, just for explanation purpose. So these are about the data types. Any doubts or queries?